This lesson, we will focus on how to evaluate limits graphically by looking at the graph and find out the limits. So one thing you have to know very clearly is when you are finding a limit, say when x is approaching to 2, you are finding the y value that the function is approaching to when x is approaching to 2. However, x is never at 2. Let's do some examples. There are 8 different graphs. We are looking at f at 2 for every single graph first. F at 2 means I want to know what's the y value when x is 2. All right, so let's start with graph 1. So when x equals to 2, the point that is defined is here, the blue one. The y value is 3, so f at 2 equals to 3. Graph number 2, when x equals to 2, there is no defined y value. So we say f at 2 is undefined. Graph number 3, f at 2, when x equals to 2, this point is defined. The y value is actually at 1, so f at 2 is 1. As you can see, this point is an empty dot. It's a hole. That means the function is not defined at that point. It's only defined at this point. The next graph, number 4, f at 2, the point that is defined here is the blue one here is at 3. Let's move on to number 5. F at 2 is right here. The blue point here, the y value is at 2. So it's f at 2 equals to 2. Next one, when x equals to 2, the y value is going to be at 3 because this is the only solid dot that is being defined. The next one, graph number 7, when x equals to 2, we don't see any point that is defined on that vertical line. So f at 2 once again is undefined. And graph number 8, same thing again. When x equals to 2, at that vertical line, there is no point that is being defined there. So f at 2, once again, will be undefined. Now, after we define f at 2, then we're going to find the limit when x approaching to 2. And when you are approaching to the values, remember, x is never 2. X is only approaching to 2. So let's try this. First graph, when x approaching to 2 and there is a plus on the right-hand side corner, that means x approaching to 2 from the right-hand side of the 2. So for example, you are going to be here. That's when x equals to 4. Your y value is at 5. And as you are getting closer and closer and closer to 2 from the right-hand side, your y value go from 5 and 4, and now it becomes 3.5, 3.2, 3.1. So as x approaching to 2, y is getting closer and closer and closer to 3. So we write down 3. And the next one, when x approaching to 2 from the left is indicated by this minus sign on the right-hand side corner. So 2 minus means going to approaching to 2 from the left-hand side of the 2. So let's look at this. So right now, say we are here. X value is 0. 0 is on the left-hand side of 2. And as you are approaching to 2 from the left-hand side, your y value comes from 1 and getting closer to 2, and then goes to closer to 2.5, 2.6, 2.7, 2.8, 2.9. So when x is getting closer and closer to 2, your y value is getting closer and closer to 3 again. And since the right-hand side and left-hand side, they are both approaching to 3, so we say the limit when x approaching to 2, y is approaching to 3. So limit when x approaching to 2, fx equals to 3. Let's look at graph number 2. When x approaching to 2 from the right, so once again, we're going to be here, and your y value is getting closer and closer and closer and closer to 3 as your x is getting closer and closer to 2 from the right. So we write down 3. And the next one, when x approaching to 2, negative means 2 from the left. So once again, we're going to be here, and we are getting closer and closer and closer to x equals to 2 from the left, and your y value is getting closer and closer and closer to 3. So we also write a 3. So since left-hand side and right-hand side, they are both approaching to 3, so limit x approaching to 2 equals to 3. As you can see here, even though f at 2 is undefined, there is a limit. When limit x approaching to 2 is 3, however, f at 2 is undefined. How can this be? The reason is approaching is only getting closer to it, but it's never at that point. F at 2 means what will be the y value of a point that is defined on x equals to 2. So there are two different things. Limit is only approaching 2. F at 2 is actually at that value. That's to graph number 3. When x approaching to 2 from the right, so your point will be here. So as you are getting closer and closer to 2 from the right, your y value is getting closer and closer to 3. Next one, when x approaching to 2 from the left, so you're here, and then getting closer and closer and closer to x equals to 2, but your y value is getting closer and closer and closer to 3. Since left-hand side and right-hand side limits, they are both approaching to 3, so limit when x approaching to 2 is going to be at 3. So next one, when x approaching to 2 from the right, as you can see from the graph, there's nothing on the right-hand side of the 2. So we say it does not exist. And on the left-hand side, x approaching 2 from the left-hand side, your y value is getting closer to 3. But since there's no right-hand side limit, so we say the limit does not exist. So once again, look at graph number 2 and 3 and 4. Now, your limits, it's very different from f at 2. The reason is they are not the same thing. F at 2 means when x equals to 2, where is the point defined at that vertical line? And when x approaching to 2 means it's only approaching to that value, but it's never at the value. All right, that's to graph 5, 6, 7, 8 now. So when x approaching to 2 from the right on graph number 5, you are right here. So y value is getting closer and closer and closer to 1. On the left-hand side, x approaching to 2 from the left, your y value is getting closer and closer to 3. Since left-hand side and right-hand side limit, they are not the same, so we say limit does not exist. Next one, graph number 6. So when x approaching to 2 from the right, your points will be here, and getting closer and closer and closer to x equals to 2, your y value is getting closer and closer to 1. X approaching 2 from the left, your point will be here, and getting closer and closer and closer to x equals to 2 from the left, your y value is getting closer and closer to 3. So since left-hand side, right-hand side, they are not the same limits, therefore, limit does not exist when x approaching to 2. And next one. So when x approaching to 2 from the right-hand side, you can see from the graph, your y value is getting higher and higher and higher and higher and higher and higher. So we say your limit is going to be positive infinity. And when x approaching to 2 from the left, your point will be here. And as you're getting closer and closer to 2 from the left-hand side, your y value is getting higher and higher and higher and higher. So we say this is also positive infinity. Since left-hand side and right-hand side, they were both positive infinity, so we say x approaching 2 is positive infinity. Let's look at graph number 8. When x approaching to 2 from the right, you are getting closer and closer and closer to positive infinity as well. When x approaching to 2 from the left, and your y value getting lower and lower and lower and lower and lower, so we say this is negative infinity. Since left-hand side limit and right-hand side limit, they are not the same, so does not exist. Okay. And there's one thing that is very important that you have to know. Limits, when it goes to positive or negative infinity, we say they do not exist. So even though we know they are both approaching to positive infinity, it does not exist. Because infinity, there is no limit, right? So infinity means does not exist. All right, so let's look at the theorem. So we say limit exists if and only if the right-hand side limit and left-hand side limit, they are equal and they equals to a constant. And you have to know positive and negative infinity, it's not a constant. So if your limit approaching to infinity, we say does not exist. And when limit goes to negative infinity, we also say that does not exist. Okay, so let's do some questions together. So by looking at this graph, I want to find the following limits. So part A, we want to find limits when x approaching to 0 from the left. So when x approaching to 0, this is where x equal to 0. From the left will be this region. For as you are getting closer and closer to 0 from the left, your y value is getting closer and closer to 0. And x approaching to 0 from the right, so you will be here. So you're going from the right, and you're getting closer and closer to 0. So as you're getting closer and closer to 0, your y value is getting closer and closer to 2. So limit x approaching to 0 from the right, your y value is approaching to 2. So since left-hand side, right-hand side, they do not have the same limit, so we say limit x approaching to 0 does not exist. Next one. When x approaching to 2 from the left, x equal to 2 is right here. So from the left-hand side means this entire function here. So as I getting closer and closer to x equals to 2 from the left, your y value is getting closer and closer and closer to negative 2. And when x is getting closer and closer to 2 from the right, so you will be here. And as I getting closer and closer and closer to x equals to 2 from the right, my y value is getting closer and closer and closer to 0. And since left-hand side limit and right-hand side limit, they are not the same, so we say x approaching to 2 does not exist. Next one, when x equals approaching to 4 from the left, so x approaching to 4 is right here. From the left means on the left-hand side of this graph. So as I getting closer and closer to 4 on the left, your y value is getting closer and closer to 4. And when my x is getting closer and closer to 4 from the right, my y value is getting closer and closer to 4 as well. Therefore, limit x approaching to 4 equals to 4 because right-hand side and left-hand side limit, they are the same. All right, so this is another different type of example. So first thing is, I want you to be able to graph the function. So fx equals to x squared minus 4 divided by x minus 2. The first thing you should try is to try to factor them. So on the numerator, I can break them down into x plus 2 times by x minus 2 and divided by x minus 2. So they have the same factors. I can divide them. So it's going to be x plus 2, comma, put the restriction down. X cannot be 2. So how does the graph look like? So this is actually a linear relation. So slope equals to 1, y-intercept is at 2, and x can never be 2. So how do I graph this? You say slope equals to 1, y-intercept at 2. You graph the y-intercept first, which is at 2, and slope equals to 1. That means go to the right by 1, go up by 1. And go to the right by 1, go up by 1. But however, x cannot be 2. So when x equals to 2, it's a whole. And you will have a linear line. So this is fx. After we graph this function, and let's go back to answer the questions now. So they say limit x approaching to 1 fx. So I can write like this, limit approaching to 1 fx. Before I can find this, I need to find what's the right-hand side limit, what's the left-hand side limit, before I can define what's the limit when x approaching to 1. So we're going to do this. We say limit x approaching to 1 on the right, and let's look at the right-hand side. Limit x approaching to 1 on the right-hand side. So 1 is right here. So on the right-hand side will be this region here. So as you're getting closer and closer and closer to x equals to 1 on the right, your y value is getting closer and closer and closer to 3. So we write 3. And we have to do limit when x approaching to 1 on the left-hand side. So once again, when x equals to 1, it's this vertical line here. But on the left-hand side, so we are on this region here. So we're on here, and as you are getting closer and closer and closer to 1 on the left-hand side, you can see your y value is getting closer and closer and closer to 3. So we write 3. Since left-hand side and right-hand side, they both have the same value is at 3, so we say limit equals to 3. Next part, we have to find limit when x approaching to 2. Once again, before I can define the values, I have to find what's the right-hand side limit, what's the left-hand side limit. So x approaching to 2 from the right, we have to look at the graph again. So 2 is right here. So from the right will be here. So as we're getting closer and closer to x equals to 2 from the right, your y value is getting closer and closer to 4. Limit x approaching to 2 from the left will be here. And we're getting closer and closer and closer to x equals to 2 from the left. And you see your y value is getting closer and closer to 4 again. So therefore, when x approaching to 2, your y value is getting closer to 4. That's called the limits. Because right-hand side limit and left-hand side limit, they both have the same constant. However, if you really look at the graph, what will be f at 2? F at 2 is actually undefined. There's no point defined at x equals to 2. However, there is a limit when x approaching to 2. Next one, let's use table values to see what's really going on to the y values when x approaching to 1. So that's another way to find limits. So limits by using a table now. So there's a function x squared minus 4 divided by x minus 2, and then we want to find what's the y value that we are approaching to when x approaching to 1. Once again, you have to do it on the right and then on the left. So let's try from the right-hand side. So as we're getting closer to 1 on the right, you can see the x value is 1.9, 1.5, 1.1. It's getting closer and closer to 1 on the right. And what happened to the y value? So let's substitute in. When x equals 1.9, your y value is actually 3.9. And let's get closer to 1 from the right. So x becomes 1.5 now. It's getting closer to 1. And your y value becomes 3.5. And when x becomes 1.1, your y value becomes 3.1. And when x becomes 1.01, your y value is actually 3.01. And when x value is 1.001, your y value will become 3.001. So we say y is approaching to 3 from above 3. Okay, next one, we are going to find limits when x approaching to 1 from the left. So say x is right now 0. So substitute 0 into the function, you get the y value is 2. And when x becomes 0.5, it's getting closer to 1 from the left, your y value becomes 2.5. When x becomes 0.9, your y value is 2.9. When x value becomes 0.99, and your y value becomes 2.99. And when x becomes 0.999, your y value is actually 2.999. So we say y also approaches to 3, but from below 3. Now, if I really substitute 1 into the function, x is actually at 3. That means f at 1 is 3. And limit x approaching to 1 fx is also 3 because they're both approaching to 3. They have the same values. The next example is a little bit different now. So let's try this. We want to find x approaching to 2. What's the y value that we are approaching to? Once again, you have to go from the left and go from the right. So I'm going to do from the right first. From the right means my x value right now is 3. It's right-hand side of the 2. And I'm getting closer and closer to 2 from the right. So 2.5, 2.1, 2.01. I'm getting closer and closer to 2, but from the right of the 2. And let's see what happened to the y value. When x equals to 3, y is going to be 5. When x equals to 2.5, y value is getting 4.5. When x becomes 2.1, my y value is actually 4.1. And x is getting 2.02, then y value is going to be 4.01. And when x becomes 2.001, my y value is 4.001. So we can see y is getting closer and closer to 4 from above when x is approaching to 2 from the right. Next one, we're going to do from the left. That means when x equals to 1, I'm getting closer and closer and closer to 2 from the left. That means 1.5, 1.9 is getting closer to 2. And let's see what happened to the y values. So when x equals to 1, y is actually 3. When x becomes 1.5 now, y becomes 3.5. And when x becomes 1.9, y value is 3.9. And when x becomes 1.99, y value is going to be 3.99. When x becomes 1.999, y value is actually 3.999. So we can see y approaches to 4 when x approaching to 2 from the left, but from below. And next, let's try this. When x equals to 2, what happened to the y value now? You can see this is undefined because the denominator will become 0. So we say f at 2 is undefined. But limit x approaching to 2 is defined. It's actually at 4. The last example is in a piecewise function. So there is one function fx and being defined by 3 different pieces. So we're going to graph every single piece in order to find the limits. Okay, let's look at the first piece. So the first piece is y equals to x minus 1. So this is a linear relation with the slope is the value in front of the x, which is 1. And we write 1 as a fraction, 1 over 1, to define the right and the wrong. And your y-intercept is the constant that without the variables beside it, which is -1. So we graph the y-intercept first, which is at -1, and we use the slope. It's positive 1 going to the right by 1, go up by 1, go to the right by 1, go up by 1. And we have many different points that we can generate. And after that, we make a line. And after you make the linear relation, make the line, you use the conditions. So the condition here is x is less than 1. That means your line can only be on the left-hand side of the 1. So everything on the right-hand side of the x equals to 1 should be erased. So let's erase them. And because there's no equal sign on the 1, so at 1 is actually empty dot. It's a hole. So that's my first piece. And the second piece is y equals to 1, which is a horizontal line with a y-intercept at 1. So at 1, and there's a horizontal line. And once again, you have to use the conditions. The condition says x can only be 1. That means you have to erase everything except for at 1. So let's erase this side on the right-hand side of the 1. And I have to erase the left-hand side of the 1. So really, you can see there's only 1 point left. The third piece is actually a radical. So we say y equals to 2 plus square root of x minus 1. Because that's a radical, I think the easiest way to graph them is by using table values. And since they say x can only be greater than 1, so I start with a 1 to find where my empty dot is and move on. So when x equals to 1, that will be 2 plus square root of 0, which is 2 plus 0, which is 2. And when x equals to 2, I'll have 2 plus square root of 2 minus 1 is going to be 3. And the next value, x value I will choose, I will not choose 3 because 3 minus 1 inside the square root is not perfect square. So I will use 5. So if when x equals to 5, I have 2 plus square root of 5 minus 1, which is 2 plus square root of 4, which is 2 plus 2, which is going to be a 4. So after I have 3 points, I should be able to graph now. So the first point is 1, 2. But remember, x can only be greater than 1. So that's an empty dot, 1 and 2. And the next one, 2 and 3, that's a solid dot. And 5 and 4, that's also a solid dot. And move on. So that's a radical function. Once we finish the graph now, so we are using the graph to find the limits. Once again, before we can find limit x approaching to 1, we have to look at what's the right-hand side limit, left-hand side limits. So first thing, when x approaching to 1 on the right, we look at the graph. On the right will be here. So follow the purple line. So as x is getting closer and closer to 1 from the right, your y value is getting closer and closer to 2. And we have to do the left-hand side. When x approaching to 1 from the left, then we'll look at the pink function here. So when x is getting closer and closer to 1 from the left, my y value is getting closer and closer to 0. And because left-hand side limit and left-hand side, right-hand side limit, they are not the same thing. Therefore, x approaching to 1 fx does not exist.